Okay, back again for more. You are on page 93. We're going to kind of put it all together here. This is, we have a lot of instructions, so we need to be careful that we've read them. They ask us to make a table of values, then graph the function rule, label the axes using the appropriate scales depending on our data, decide if the graph is continuous or discrete, and find the domain and the range of the situation. Now, one thing we don't have to do is find the equation, because they give us the equation in these examples. So they're telling us that this equation represents the total weight, and they're using pounds for the weight, of a spa containing some amount, G, gallons of water. And this is an important piece of information for our graph and our domain. The spa contains 250 gallons of water when it's full. No more. Okay, so we're going to go make our table. Our input is going to be the gallons of water. That's our X, our independent variable. The weight is going to depend on how many gallons are in the tank. So if we use this formula right here, obviously when there are no gallons of water in the spa still weighs 700 pounds, empty. When you scale it up, and I'm going to go up by 50s, it doesn't make sense to go up by ones. I'm going to go up by 50 gallons. If it contains 250 gallons, I got to get to 250. And we'll be here all day and night if we try to go up by anything much smaller than 50. So when you plug in 50 for 8 times 50 plus the 700, I get 1100. And then I'll go up to 100 and plug it in, and I get 800 plus 700, so that's 1500. Go to 150, and I get 1900. And I hope you're satisfying yourself that these numbers are correct, because I do make mistakes. 200 plus you need some practice setting up these charts. Gets me, I think, to 2300. And finally, when I'm at 250 gallons, I'm done. This is the max it's going to weigh, 2,700 pounds. So if I go over here and I plot this, what makes sense, and be sure to label your axes. We have gallons and we have the weight, and this is in pounds. Makes sense, we went up by 50s, so I'm going to quickly do my intervals here. And that says 250. And I'm going up by, I'm going to go up by 500 pounds because I've got to get all the way to 2,700. So I'm going to go up by 500, 1,000, 1,500, 2,000, 2,500, and 3,000. So it's important when it says appropriately labeling and scaling the axis. That's what this means. You've thought about what your intervals are going to be. You've spread your data out on the graph that you have in front of you. So if we go to plot the points, 0 to 700, it's about in there somewhere, 50, 1,100, we're eyeballing it, 100 to 1,500, 150 to 1,900, which is about right there, right underneath the 2,000. 200 maps to about 2,300, and at 250, we're at our top weight of 2,700, about right there. So you can see this is linear. It does form a straight line. If you were to take a straight edge, you would get a straight line. And now we're going to answer some of the questions. So is this continuous or is this discrete? So it is continuous because you can have a fraction of a gallon of water. We have nice round numbers here, but there are valid points everywhere on this graph for fractional parts of a gallon of water. So yes, it's continuous. There's no breaks, no gaps. And finally, we need to write the domain and the range. So we're looking at what is reasonable. Where does our x-axis start and where does it stop? So the x-axis actually stops right here. So I really shouldn't even have any graph out there, and starts right there. It starts with 0 gallons, and 250 is where it ends. That's what I said, we're going to use that data right there. If you keep filling it up, it's going to run over. It's not going to hold any more water. So the domain, and that's our G for gallons. That's the variable we're using. He is greater than or equal to 0, because he could be 0 when the spa is empty. And he is less than or equal to 250. So anywhere in there is a valid amount of water to have in that spa. But it does have endpoints. So this is an and condition. The range, and that's going to be for the weight. So we're going to start with the weight. I'm going to go ahead and just put my inequalities in here and see if we can figure out where are our numbers. What is the bottom number for the y-axis? There he is, right there. And that's where our spa is empty. 700 pounds is the least he is going to weigh, all the way up into and including the 2,700 when the guy has 250 gallons in him. Okay, let's do this one real quick. This one is a totally different problem. They give you the cost in dollars for baseball tickets. So obviously these baseball tickets are 16 bucks each. This one will graph a little bit quicker because the numbers are a little more friendly. 0 tickets, $0. 1 ticket, 16 bucks. 2 tickets, 32 bucks. Doesn't look like you get a break, a volume discount. 3, 48, and 4, 64 bucks. So if we go over here and we start labeling 1, 2, 3, 4, and we go up by tens, 10, 20, 30, 40, 50, and this of course is cost in dollars, 60, 70, and this is number of tickets. Make sure you label your axes accurately and you do your intervals. Now they ask us, we plot our points. Okay, so we start with 0, 0. That really doesn't make any sense. So you can put 0, 0 in there, but it doesn't really make any sense. If you're not buying any tickets, you don't need this rule, for sure. So we start with 1 ticket. 1 ticket is 16 bucks. So that's right about up here somewhere. 2 tickets, 32. 3 tickets, 48, right close to 50. And 4 tickets, 64. About right there. Okay, all well and good. That's a straight line. Oh, it's not a straight line. Lost my train of thought. Sorry. Come back, come back, come back. Let me put these points on. So 1 ticket is 16. 2 tickets is 32. So I was about to draw a straight line to answer whether it's continuous or discrete, but it's not continuous. It is discrete because you can't buy a half of a ticket. So none of these points in between 1 and 2 make any sense for this particular function. So there are gaps in between the points, so this is discrete. And our range and our domain are individual points. So the domain starts at 1, because we're not considering 0 tickets a viable option, 2, 3, on up to, technically, until the tickets run out. And the range is going to start at 16 bucks for that first ticket, 32, 48, on and on and on and on. So when you have a discrete graph, you have individual points on your domain and range. When your graph is continuous, these are the and conditions like that graph right there. Okay, thanks for watching.